I'm going to talk about Angular 2 and Firebase today. So who here has tried Angular 2 already? Okay, cool. Who's tried Firebase? Okay. And anyone who's done some Angular 1 development but no Angular 2 development yet? Okay, wow. All right then. Just a side note, I fell asleep at about 1 a.m. last night and woke up at 4:30 a.m. because I was supposed to do a dry run with somebody at 5:30 and they didn't show up. Sympathy noises. Okay. And so I'm glad Tracy decided to put me last tonight so that I can be fully sleepy as I present. So if I doze off or something, I may start jogging, and you'll just have to excuse me. So I'm going to talk about these two things. I'm a big fan of both of these projects, but also a fan of these other projects, Typescript, ES 2015 that Jay talked about, 2015 plus actually. I'm going to show some things that are earlier on in the spec process, as well as System.js and a project called Angular CLI. I think I mentioned RxJS, right, Ben? Did I do it? Okay, good. Angular CLI is a really new project based on Ember CLI that I'm going to talk a little bit about. So I'm Jeff Cross. I'm from the Angular core team at Google. That's my Twitter. You see I have 2.7 million followers. That's not a lie. I've been working hard at it for some time. You can go check it out. So if you saw the original description of this talk, you probably know I was supposed to do it with David East from the Firebase team. And these are two pictures. David East and I actually have a bi-weekly lunch meeting every Monday. And this is usually how it starts for half an hour. Me on top, sitting there by myself, eating my lunch. And then David East shows up later, and I usually tweet and shame him for it. The same thing happened tonight. He decided to go down to LA, and I don't know what this picture is of, but he posted it last night. He's overlooking a beach or something. He has some mandatory work event, so he left me to give this presentation myself. So I wanted to take the time to publicly shame him for that. But thanks to Cato Wolf from the Firebase team for his help in preparing some of the things that I'm going to show tonight. He didn't let me down, except this morning. He was the one supposed to attend my dry run, and he forgot about it at 5:30 in the morning. So Angular 2, I said in the announcement slides, we're now in beta. That's a really satisfying thing for us because we've been working to get towards that for a long time. And beta for us isn't what you normally think of beta. We had a pretty high bar for what we would consider beta. And it's actually pretty stable. It's already being used by a lot of teams at Google and outside of Google. AdWords is building on it. We've got apps in production at Google with it already. So the core is relatively stable. We just wanted to build out around it, build the other missing pieces to make it a great platform before we call it stable. But it is beta. And so there are some rough edges. There are some things that are not great right now. Like our docs are pretty good, but they're still a little bit overwhelming. A lot of the concepts are still overwhelming, and there are things like we need to work on getting the size of our assets down. But I want to show how to build an app with Angular 2 and with Firebase. And to do that, I'd like to use a real app instead of something conceptual. And this is actually an app we're working on building as something that our Google developer experts can use. It's a forum type app. And to start, I used Angular CLI to generate this project, but for the sake of time, I'm not going to do Angular CLI right now because it has to download some stuff and install and set up some things. But we have Angular CLI, which is a fork of Ember CLI, and we worked with Stefan Penner and some other folks from that project to come up with this. And this is a similar experience where you just generate apps, generate components, generate services easily, and it sets up the build for you. So then you don't have to worry about building for distribution. It sets up your tests, sets up your testing framework. This project is really early, but I'd encourage you to install it and try it and build some apps with it, knowing that there are many rough edges on it. So let's look at the app that we built. It's a simple app. I couldn't log in earlier because GitHub was down, and I'm using GitHub to log in here. But I think it's back up, right, Ben? All right, Ben says it's back up, and we're good to go. So it's a basic app. We have some answers, or some questions people can ask, like how does Firebase work? And then we see some answers here. And then you could also add your own answer. So I'm actually using me see here. I'm actually going to use CLI to serve the app locally. And it will use library load and which Tracy, I know you're living without now, but library load is a really nice tool. So that as I make changes, it will automatically build the app and then will reload the browser automatically. So let's look at the code for the app, and I want to talk through some of the concepts of Angular, and then we'll get more into Firebase and how the two play together. So we'll start by looking at the first logical place. Let me close the... How's that code size? Is that okay? People in the back, too small, too big? Good? Okay. Let's open the index.html. Can't even see the paths here. Wrong one. So nothing special. We load some polyfills. I load Bootstrap. We load RxJS. Right, Ben? Yeah, all right. Ben is the maintainer of the new RxJS, so I have to say it at least 5 times in the talk, I think, right? 5 times, okay. I've said it 3 so far. And then we load Angular. So right now we just have bundles to make it easy to develop with Angular. And then we have this interesting thing down here called system config. Has anyone used the system.js loader in a project? Wesley, I know you have. Anyone? Okay, so not very many people. So it's something that we're using now, and we've been using for some time. And it's kind of based on what was the ES6 loader spec, which then got moved around committees and is now being picked back up again. So it's loosely standards based. I couldn't tell you how close they are to the new spec. But it's a way of dynamically loading modules rather than using a script tag. And you can load other things too, any kind of asset really. But here, so we're configuring it here. And what we're doing is saying map. So when something loads a module from Angular Fire 2 / something else, or Firebase / something else, here's how to resolve it. And so we say Angular Fire 2 points to this path. So it'll load all submodules there. Firebase points to a specific file. RxJS points to a specific path. And then down here, we just set some more configs for each package, like the format it uses and the default extension, so we can request files without saying .js on each file. And then we use system to actually load the main file for our application called app.js. And so this is pretty much standard with all frameworks. I don't know, maybe not. You'll have an app.js that does the work of getting your app set up and into the browser. So let's look at that file and talk about how to bootstrap apps with Angular 2. Close the side here. So I was hoping Jay would talk a little bit about this, but he says he didn't want to. These are ES6 modules that we're loading up here. If you've used Node or any other module system, you know the ideas of modules. You have modules that have different symbols that get exported, and then you import them here. This is just the standard ES 2015, not ES6 way of importing things. So we're importing several things. We're importing the basic things that we want to set our app up with at the beginning. I'm going to skip over that right now and look down at the bootstrap. So in our bootstrap method, this is something we imported from Angular 2. This is a function that the Angular exports. We're giving it 2 arguments. The first argument is this thing called Angular Fire Demo 2851 app. Sorry for the numbers. I just generated random numbers as I was throwing away these projects. And then we've got this array of things where I'm saying things like provide default Firebase, auth, Firebase. We'll talk about that second part later. So those of you who did Angular 1 applications, you probably, this is familiar because we had Angular.bootstrap, where you would give it the root element of your application and then the module that you've already configured. Angular 2, it's different in that instead of giving it an element for the first argument, you're actually giving it a component class. And then Angular looks at that component to figure out what element it needs to take over inside the application. Another different thing about it is it's a lot more dynamic than Angular 1. Angular 1, you have to have your module configured, all your providers ready to go, and then it's done by the time you bootstrap your app. There's no more changing it. Angular 2 is a lot more flexible. You can load things lazily. You can change your dependency injection based on your components. That's a lot more flexible. So here's the basic difference. Document in my app module and bootstrap component, and it doesn't require the second argument. So components. I think every framework has some idea of components now. The web is also developing its own idea of components. Angular 2 components are their own thing, and they have some interesting properties. One is they're self-contained. So a component shouldn't leak details to the outside, and it should only have explicit relationships with what's outside of it. And they're really the building blocks of Angular 2 applications. So in our app where we have questions and answers, we have the app component at the root. We have a logging component that's inside of it. We also have a question list component that we'll look at inside of it. And as a child of that, we have a question detail component. So that components can stay self-contained and encapsulated, Angular components have an explicit input-output contract, or a component can describe the inputs it can accept from the outside, and it will also describe the outputs that it can send out. Another way to refer to it is properties and events, which is what they used to be called in Angular, but we changed it to disambiguate. So inputs are things that you can set on child components, and outputs are the events that your component can emit. So let's take a look at our app component, this app that we're bootstrapping here. I have to open my side here. Okay. So again, we're importing some stuff. Let's go down and look at what the component looks like. First thing you'll probably see if you've not used any experimental ES 2016, or I'm not sure what it is, features. This might look weird to you, this at component, and this is called a decorator. This is something that it's not new to programming in general, it's just new to JavaScript. What this does is attach metadata to a class that Angular can then look at. When it looks at a class, it can look at how we've described it with this component metadata to know how to render it. So in our component annotation or decorator here, we give it a selector. What this is an a tag name that when Angular sees this in the template, it knows it can replace it with this component instance. And then we give it a template URL that specifies the view for this component, the view that the user will see. And then we specify a list of directives. And this is a list of components and these things called directives, which I'll talk about in a second, that can be contained within my component. Now, this is different from Angular 1 because when you would register a directive in Angular 1, it would just replace that, whatever matched that selector anywhere in the application. In Angular 2, we're more explicit about it, where in a component you specify what directives will be in the view of this component so that there's no risk of name collisions, which for bigger apps was a problem with Angular 1. And also tooling is a little bit easier this way. So IDEs can give you more assistance when it sees you misusing a directive in a template or things like that. So one good way I think to think about decorators is it's our way of telling Angular something about something without Angular having to actually execute code. Angular can just statically analyze code. And I like to think of it as a love letter. And my friend, my teammate Alex actually recorded a love letter to Angular as a decorator that I want to play for you.
My dear Angular framework, this class is a component, and I've decorated it for you. I've decorated it so that you can know whenever you see an element with a tag that matches my login selector in the template of any other component, please, for me, create an instance of this component. I've included the template for this component in line so that no follow-up requests are necessary. I know that you like to know how to structure the view for this component. Also, I've attached the styles that should be included with this component, and if you could be so kind, would you just please prepare the providers specified in the providers array and inject them when this component gets instantiated so that my component has everything it needs to do its job. I've gone ahead and I've listed all the other components and directives that I intend to use in the view so that you'll know exactly how to process this component's view without any fear of name collisions with components that have a similar selector. I really hope that we can work through this together and you'll make my application work. Thank you so much, Angular. I really appreciate it.
Did you feel the passion there? Yeah, thank you. Here's are a function, but all they do is attach this metadata to a class or a property, and then when Angular looks at this class, it looks for the metadata and figures out how to handle it. So that's the metadata. Here's the actual class implementation of the app. It doesn't really do anything other than set something here. So one thing I haven't talked about yet is that this file is a .ts file. So if you've used Typescript, you know what that is, but all that means is this is a Typescript file. Typescript is a superset of JavaScript, so everything in this file is actually ES 2015 plus JavaScript. But right here is probably the only place where we deviate from just standard JavaScript, because I have this annotation that's saying :auth. And auth is a type, and by saying this, I'm telling the application that the thing that will be injected here is of this type. And by using this public keyword, I'm actually setting the auth property as a public property of this component. So it's the equivalent of saying this dot auth equals auth if I didn't have the public there. So if you're familiar with Angular 1, you know we had this thing called directives, and directives were basically the thing you used to put your app together, directives and services. And so now we're talking about components, and we have this component-like thing in Angular 1. So we still have directives in Angular 2. So the difference between a directive and a component is actually kind of a subclass of directive. A component is just a directive that also provides its own view. A directive is attached to something that already has a view. And so both modify the behavior of what they're attached to. So this is a question and answer app. We want to be able to log in, and so we want to create a login component. Now let me show you how the login works. Are we still good on GitHub? GitHub's on? Okay, good. So I'm going to log in with GitHub. Oh, and it just worked because I've already logged in before. And then it says welcome here. So this is our component right here. It shows a login button when I'm not logged in, and shows log out when I am logged in. So I think that's pretty simple. So let's look at, I think we've got some imports at the top. I'm going to skip over those for now, except for this one, this replay subject from RxJS. That's a good one. All right, so we've got another component, but this one's a lot bigger. We've got all this junk here, all this markup that does stuff. Let's talk about what it does. So first we have the selector. So this is basically a subset of CSS selectors. So what you give here, I could say like dot to say it's a class, and it would match any element with that class name. But this matches a tag name. So anytime a component that brings this login component in has an element that says FB login, it'll get replaced with this component, and this markup will all get inserted in its place. So let's look at the template. And first let's look down at the class implementation, which we see is just as simple as the other one. All it's doing is setting this auth service here. I'm going to talk about how Angular knows how to set this, because Angular is the one who's actually instantiating this component when it runs into it in the view. But first, I want to look at this auth service that we've seen in a couple places, and then we'll come back to how it's implemented in the logging component. So let's open that. So this service is what we use to communicate with Firebase to log in for the application. And Firebase makes authentication really easy. Actually, it's one of the three main things that Firebase does. And so some of you have used it, so you kind of understand what it is. But Firebase is a database that's in the cloud. You don't run it locally. You don't deploy it yourself. It's completely as a service. They made a name for themselves by doing the real-time synchronization, like really fast, low latency synchronization between clients that are connected. But they also do really simple authentication, where you can easily log in with a third-party OAuth provider like Twitter, GitHub, Facebook, Google. You can do your own custom authentication provider, or you can do basic auth. And then they have a nice, fast, and simple hosting service. So here's the service we wrote for this application to manage the login process. So inside of here, inside our class, we have methods for login and logout, and our constructor is doing some stuff that we're not going to worry about right now. So anytime something calls this method login, it's going to call the Firebase Ref. This is something from the Firebase library, and it's going to say auth with OAuth pop-up, and it's going to say GitHub is the provider I want to use to log in. So I've already configured GitHub on my Firebase as a provider, and so when I click login, it's going to do this, and then if there's an error, it's going to call error on this login state thing. So I've actually added something in this component that makes it a little bit easier to work with Firebase, and that's this library called AngularFire 2. So people who've worked with Angular 1, have you used AngularFire for Angular 1? Okay. It's a pretty popular library. I think it's one of the most popular Firebase web libraries. We've started work on an AngularFire 2 version, and we just released it yesterday. It's an early alpha. It's really just a couple of weeks in, based on a long time of talking about designs and things. We're working on it on the Angular team with people from the Firebase team. Before, they had just done it all themselves, so now we're both working together to make it a really great library that really embraces the concepts of Angular and Firebase in a great way. So I've installed that already, and I have some things up here that are accessing, or that are coming from the AngularFire 2 library. One is called this default Firebase Ref. And what this is it's an instance of a Firebase object that I can interact with to change data and subscribe to data. But I don't have to instantiate it in each component I have. And this is nice because I would like to configure the URL that I'm connecting to somewhere else other than every single component. And I also don't want to do it as just something like a constant in a config file somewhere, because I'd like to be able to change it for different environments and different testing environments, like staging environments, without having to hijack a module loader to tell it how to find the right URL. So we have this convenience where I can inject a ref that's already configured, and then I can immediately check the authentication state synchronously. And then on this login state thing, which I still haven't explained, I can emit the state. I can say, is the user logged in or not logged in? And I can also attach the auth object. So any place that has a hold of this service, which we saw 2 places so far that do, can subscribe to these changes and see as the state changes. If the user logs in, they'll be notified. If the user logs out, or if something happens, then all components in the app can stay up to date by subscribing to this service. And then also in the logout method, we just have unauth. And you see in these login and logout, we don't actually have any listeners for the success event. That's because we registered this handler in the constructor that says onAuth, which gets notified anytime the authentication state changes. Okay, so we've seen the service. Now let's go back to the login component. And we'll come back to some of these things in a little bit. But actually, let me show you one more thing. So in app.ts, we skipped over this before. This is where I'm actually configuring the default Firebase Ref and giving it the URL that I should use throughout my application. And then Firebase providers, this is a convention in Angular that if you have a library that provides something for Angular, it will export it as whatever underscore providers, and then you can use it when bootstrapping your application so it can be configured. So what is this array here? And how do we get this auth service that is attached to our components? Angular has this concept called dependency injection. And this isn't an Angular concept. It's just a concept we really latched onto and really have stuck with even since Angular 1. We've made it a lot different in Angular 2. But the basic idea is you have providers and injectors. Providers are just some way of configuring something that the rest of your app can consume or use in some way. So in this case, we've got a provider that I'm configuring here that says whenever somebody asks for default Firebase from an injector, just give them this string value. And then if they request default Firebase Ref, which I was requesting in auth, it will give them a instance of Firebase based on this string value. So it actually depends on this. I can also just pass a class here, like auth is just a class, and it will just create an instance of that class whenever somebody asks for it, and it will share that instance everywhere. So it's a singleton class that gets shared for any place that asks for it. And the Firebase provider just does its own work to get things ready for the application. So I've got a simple example over here too, where we could have a local store library. And so one of the reasons why dependency injection is so nice and so powerful is testability and mocking. With dependency injection, I can take any token, like local store in this case, which in the previous slide I was just binding to the class itself. And I can say, for any time somebody asks for this, instead use this other implementation. So I can just use in-memory local store if I wanted to use it for testing, instead of actually writing to disk and slowing down my tests and maybe having side effects that I don't plan for or flakiness I don't plan for. And then my component doesn't know any different. It's injecting local store because it's the type parameter here. So Angular works with Typescript pretty well. This is one of the features that actually is TypeScript specific, where if a type annotation matches a provider, then it will just get injected in place and you don't have to do anything else to tell Angular about it. But it also needs to be a real type that you put here. And another note is that Angular, it was built with TypeScript as the primary first class experience, but it also works well with ES5 and just plain ES6. You just have some trade-offs, like if you use ES5, you have to do decorators a little bit differently. So that's a little bit about dependency injection. And we've looked at the login service, where I can just log in here, and I didn't have to do anything other than call that method, and I already configured GitHub. So has anyone ever actually implemented OAuth flow themselves on a server? It's not very fun, huh? Yeah, it's always different too. Nobody actually implements it the same. Yeah, lots of edge cases to think about. So the fact that they do it seamlessly and you just throw it in your app and it's just one method call, that's a pretty big win. So let's go back to the login component. I know it's such a simple component, we're spending so much time on it, but it's a pretty important one. So we'll go into app components. And by the way, Angular CLI generated, I'm in dist. Angular CLI generated all of these for me. I just ran ng is the program name. ng generate component fb login, and it created the file, the test, and it also created a template that I deleted. And so all I had to do was create this and then edit it to look how I wanted it to. So let's look at the template. There's some weird stuff happening here. First off, you see some square brackets here with an ng switch in it, and then over here there's something that looks like an expression. I don't know. So Angular templates in Angular 1, I think they were actually pretty close to what other frameworks and template libraries were doing. You know, we had double curly brackets. We had some pipes where you could filter things. That was probably a little bit unique. In Angular 2, we went a little bit further. And actually, I've got a cheat sheet here because there are some interesting things. So we introduced some new concepts inside templates, but what this gave us was a lot of things we could remove from the framework. Like there were lots of directives just for binding to events of elements, something like 25 directives that we could just get rid of that we had in Angular 1 by having a slightly new syntax. So let me just explain the syntax really quickly. If you see things like the star ng switch when, that means this directive makes structural changes to the template. It will change the shape of the template, like removing or hiding or moving things around, moving elements around. And these things on the, in the little diagram here, you see like these right side expressions, logged in, logging in, logged in. These are actually expressions that get evaluated against the parent component. So here on the slide, we see an ngIf. I didn't realize how small that was going to be, so I guess I'll use the left-hand example here. So here we see ng switch when. This is actually saying when the case passed to this matches this literal string not logged in, then it will show this button component that the directive is attached to. And what these square brackets mean are setting a property value of that element. So square brackets set a property, and some directives work that way where you can set a property. And then these parentheses are binding to an event or an output of that element. It works with native DOM elements or custom components. So here we're saying when the button is clicked, call on my parent component called auth.login. So on the login component, it's calling this .auth.login whenever someone clicks this button. So it's a lot to look at first, but it's actually really powerful. And not only does it help us remove a lot of directives and a lot more code from the framework, it also makes templates more toolable. So IDEs like Visual Studio, WebStorm are in the process of making good tooling so that when it sees templates and sees how you're setting properties or listening to events, it can know if those are mistyped or if they're being used the wrong way or things like that, and give you hints inside the IDE to help you prevent making mistakes. And with Angular 1, this was a big sore spot for a lot of people. By the way, how am I doing on time?
5 more minutes.
5 more minutes? All right, I'll go really fast. Okay, so I skipped over something before in the login component, which was, actually it's now in the logins, the auth service, which is the login state. So you see it in my class here, and this is a cool TypeScript thing. I can define properties right on my class and instantiate them, so if I don't have a need for a constructor, I can just create them here. So things like this where I'm just creating a replay subject, it's simpler to do it up here, and I can also declare private properties. So login state is a replay subject with a type of auth status. Can anyone tell me what a replay subject is? Ben?
It's a type from RX that is a subject that when you subscribe to it, it accepts multiple subscribers with multiple cap.
Mm-hmm.
And every value that's pumped through it will be cached and saved and replayed to the next subscriber.
Mm-hmm. So here I'm using it, and this is a basic, a naive implementation of it, but it will, this is what other things, when other parts of the application, other components want to subscribe to the auth service, they'll actually attach to this and create a subscription to it. And then as I pump new values into it, they'll all be notified of those. I just want to take a moment to say thank you to Ben Lesh for all his help. Angular 2 uses observables in a lot of places. Ben is the maintainer of RxJS. He's done such a good job helping us. And is that good? All right, good. So he's always available when I am him asking how to do complex things with observables. I don't want to try to explain observables right now. I don't really have time. I think of them as like a promise and an array had a baby. Because with a promise, you can deliver values asynchronously, but only one value. An array, you can have many values. And you can do all these cool transforms like map, reduce, filter. An observable is something that can have async delivery, so it can wait for values to be emitted, but it also can emit many values over time. So unlike a promise, which just maybe resolves once, an observable can push and then push and push. And so for our service, that's perfect because the login state is constantly changing, so anything that's subscribed to it is getting notified with those changes as they happen, and they can react appropriately. That's why it's called reactive extensions. So let's look at the app component and how it is consuming that observable, that replay subject. A replay subject is a subclass of observable with some added goodies. let's see. So in my template here, I've got an ng switch. So this is just like switch in JavaScript. It's a directive provided by Angular. And then I have an expression on the right. So I have this auth, which is the auth state service we just looked at, and the login state, which is the replay subject. And it's got this weird character called a pipe here. And then this end of the expression says .status. So this is similar to Angular 1 filters, for those of you familiar with Angular 1. Pipes are a powerful way of being able to transform values, but also unwrap values like promises and observables. And this async pipe, that's exactly what it does. It can take an observable on the left-hand side, which the login state is, and it can subscribe to that and wait for values to come to it. And while it's waiting, it just returns null to Angular. So what goes to the view, what Angular sees is null until there's a value. And then when a value comes in, it can tell Angular, okay, I've got a new value. You need to check this and update the view with it. So here, in parentheses, this is just me scoping this expression to say, I want you to just pipe the latest value from login state and then read the status. And each of these switch statements will say, if the status is logged in, show me the question component where a user can ask a question. If they're not logged in, show them an alert that says they need to log in order to ask a question. And by default, while we're waiting for the authentication state, we just say that we're checking authentication. So there's a simple example of how you can bind an observable to the async pipe. There are other pipes included with Angular, like date and number and some other things. So we looked at that. Let's take a quick look. I know I'm running out of time. It's really Jay's fault, though, because he went way over, didn't he? It was boring, too, right? He's not here, is he? Oh, no, not different Jay. Let's look at my question component. I have like 3 question components. I can't remember which one I wanted. All right, question component. So here we have, this is the thing when I'm logged in that I see this little form here where I can ask a question. Where's Jay? And it posts down at the bottom of the list, and I see there are no answers for it. So to do that, I just have a form. And I've got another weird template thing. There's this hash symbol with ask question. What this does is assigns a local variable inside the template to whatever expression is here. This is part of Angular's forms design, where in my component, now that I've set this ask question, I can use this viewChild property decorator that Angular provides to set that component instance, that form instance, to a property in my component. And then down here, in this method that Angular calls, I can subscribe to the submit observable of that form, which is another RxJS observable, do some operations on it to figure out the value of the question field, and then push it to Firebase. I'm not going to explain everything that happens here. But so I push it to Firebase and then wait for it to succeed, and then ultimately I change I reset the form field and wait for the next question. So I already showed you how to ask a question. So Firebase, this is really easy. I could easily just push an object to it. But what's cool about Firebase is they have a declarative language for being able to set security rules. And actually, I've pushed this demo app to GitHub, and I have the security rules checked in that show how we prevent certain users from being able to do certain things based on if they're the owner of the question, if they are logged in, and they cover our bases. And you could try to exploit it and help find a weakness if you want. I would appreciate that. Actually, I'll show you the rules really quickly without going into them. So here's how it looks. So I have my questions list, and then within it I have individual questions, and then on each question I have answers, and then I check things like, is there a body, etc. So I'm almost through. we have the question detail component. This is the thing used in the list here, where I see the answers on the right, or the number of answers. Let's take a quick look at how that's implemented. And I know everybody's itching to go, so I'll go as quickly as I can. So here, we're actually referencing an external template. We've got some similar things that we saw with the other form. So we're getting a hold of the answer form from our template. I also got a hold of, this is an input that I've declared that any parent components can set this property of me. And I'm doing something similar here where when I'm watching the form, so here I'm setting something where I'm listening to a Firebase. This is something from the Angular Fire library, Angular Fire 2, so that I can watch the answers and keep it updated. But I'm also watching the submit event of the form and doing the exact same operation as before. But I'm just posting answers this time, and when it's done, it resets the form. But let's look at the template and see how it's implemented. So we just have a button that lets me expand the class. This is the button that has the answers over here, the number of answers. So this is using a directive called ngIf. So remember I said if there's a star, it's a structural directive. That means it's changing, it's like removing this component from the DOM when this expression over here is false. And then we're doing something, we're calling the count answers method on my question detail component with the question to see how many answers it has. And over here we see a button that only shows up when the answer or the question is expanded. Gives us a little closing button. And then if it is expanded, we want to show more detail. We make the question a full heading. We have a panel that shows the answers. Let's look at that. And then, so we have some answers already. And I can say, stop asking, answer it again, and then it automatically shows up. And I can also, Firebase has this cool dashboard where I can see the updates in real time. And so I see over here right away, this was added. And I could also, I'm not going to create something in there right now because it's too hard to type. But yeah, so that's basically the application in a nutshell. Oops, where did I go? So last thing is that we have with Angular CLI, we already have a Firebase hosting plugin. David East, the guy who bailed on me, actually created that. And so it makes it where after you build your app, you can just do ng Firebase deploy, and it will deploy to the hosting environment. You can actually go to my app and spam it and stuff now because it's already been deployed to deploytest.firebaseapp.com. So this is we just released this Angular Fire 2 library yesterday. It's really early alpha. Just in doing this demo, I found a bunch of bugs with it that I've opened up. It doesn't do much right now. It's got some nice utilities just for injecting a Firebase and also bringing an observable of a list from Firebase into a component. So we're adding more things like a better Angular CLI integration, better authentication and integration with router. Server-side rendering, we have a project where we render Angular apps in the server. We also are doing web worker running of applications that we're going to support. And more pipes to be able to just put URLs or paths inside a template to be able to get references. So that's it. So I'll share these slides, and I've got some links to different things I've talked about, and that's it.